Tell us your name and tell us about your project.
My name is Hans Geiger, and my project is the Geiger-Marsden experiments. And this experiment was to project an alpha particle beam at a piece of gold foil and just see what would happen.
What were you guys trying to do or find?
So when we were shining this alpha particle beam at this gold foil, we were trying to find how it would deflect. We were expecting it not really to deflect in any way, and we were trying to verify if this would be the result.
Where did the project or experiment occur?
This project occurred at the University of Manchester in England, where I was a research assistant to a physicist at the time.
What other significant events were happening around the world at that time?
Just before we had conducted these experiments, J.J. Thomson, a few years back, had conducted his own experiment called the cathode ray experiment. And this experiment determined that the atom had a model called the plum pudding model, which stated that the atom is a positively charged space with electrons inhibiting it. And that was what we considered to be the model. And that is what we had hypothesized in our experiment, and was trying to make sure that our deflections weren't very significant in any way.
Who else was involved in the project?
So my boss, Ernest Rutherford, who was a physicist, and a very well-known physicist for that matter, was conducting the experiment, and he had me be the assistant. And then I had a partner, his name was Ernest Marsden, and he had actually made a huge discovery when we had ran the experiment. He had found that the beams of the alpha particles were actually deflecting at very, very large angles that we didn't really expect was going to happen, and it was contradictory to the current hypothesis that J.J. Thomson had supposed.
What was your role in the project?
My role in the project initially, so we had initially started on shining alpha particle beams through a zinc sulfide composite in a screen. So we would shine that, and I would count the amount of rays that would pass through. And then when we had moved on to a gold foil model, I would measure the angles at which the alpha particle beams would deflect.
What impact did your project have on the physics community?
So once we had discovered that these alpha particle rays were deflecting, and in some cases reflecting back at us, we had decided that there needs to be a new model, because J.J. Thomson's model was now disproved by our experiment. So we had developed the Rutherford model, which shows that the atom has a nucleus that is positively charged and has electrons orbiting it. We had also discovered that there may be two new particles that are located in the atom: the proton, which is positively charged, and the neutron, which has a neutral charge. And this is significant because this is how the current model is in modern physics, and is what we use today.
What are you famous for?
So I am famous for the Geiger counter. After the gold foil experiments, I decided to take alpha particle beams, alpha particle detection further, and I decided that I wanted to see if we could detect other particles, such as beta particles or ionized photons. And this led me to invent the Geiger counter, which detects a lot of radiation. this is still used today in order to detect radiation in a lot of different scenarios.
Thank you.
Thank you.